Hi there, my name is Richard Malligan and I'm an systems engineer at DataJar, and welcome to this session. So this session is on Unified Login. So if you're new to Unified Login, hopefully this would be a good kind of introduction to it, or if you used it in the past, hopefully it'd be a nice refresher. So for any Apple admin, this is a really good tool to kind of utilize for troubleshooting. So for this session, I'm going to look at kind of a couple aspects of it. So we're going to have an introduction to Unified Login. So we're going to look at things like log levels, subsystems and categories, and then specifically the log command, because the log command is where you get the full power of Unified Login. It's where you can go down and drill through your historical log files and try and get the information you're interested in. And in relation to that, we've got things called predicates, and predicates will allow you to filter, to perform searches within your logs. So to start off with, if you take like Mac OS, Mac OS has been used traditional log files, Unix log files for years. I mean, it still does actually. We've got these .log files, we've got these .asl files. So we have lots of these kind of typical Unix log files within Mac OS and other systems. They're generic text files. And the problem we have though is that we end up with one or more log files per application. They're not necessarily in the same place, and they can be all over the place. So it makes troubleshooting quite hard, because you have to identify which log file is related to which application, and then you're hoping that the format of the log is readable. Maybe you want to pass it into another system. Okay, so it can get tricky. So Apple decided to kind of go down another route, and so they came up with an idea of kind of bringing or developing a unified login system, a login system to rule them all, basically. So Unified Login was introduced in 2016. So its purpose was to be a centralized login system. All the logs have standardized login format. So if you can read one log from one application, you can read it from another application. It's designed to maximize information collected, but also have a small footprint. Because what we don't want is a login system that takes up resources when you're creating the logs, and taking the resources away from the user. So it's designed to be very compact. It's got a very small footprint. All the messages are compressed, and it defers a lot of the work to observation. So things like formatting, the formatting of the log doesn't actually happen when the log gets generated. That actually gets formatted on the fly when you observe it later on. Okay, Unified Login does manage the life cycle, so it does rotate these logs, and your mileage does vary, but it will handle it for you. And also, like most Apple systems, privacy security is kind of key to this. So what we don't want is a login system that's going to leak data like passwords or credit card numbers. Okay, so it's designed to redact what it considers to be kind of private information. One great thing about Unified Login, it runs across all of Apple's platforms. Okay, so since macOS 10.12, it runs on iOS 10 onwards, tvOS 10 and watchOS. So you've got the same login system, so you can use the same tools to grab logs from all these types of devices, which is really handy. So the login system doesn't use text files. Instead, we have these .trace_v3 files. So these are compressed binary files. They're not documented, so you can't use a typical text editor to parse them. So instead, you have to use the tools Apple provides. And they generally live in var_bd diagnostics, so they tend to live in there. And the main area is this persist directory. So Unified Login maintains approximately 52 of these files, and they're about 10 megs in size. So that kind of dictates kind of the refresh cycle as it kind of cycles through. So if you've got a system that's logging a lot of information, it's going to churn through these files faster than maybe a more quiet one. Okay. So you have to use the apps that Apple supplies. So we've got the console app, which is the GUI app. That has some limitations. So the GUI app can only stream logs. So it can't be used to search historical logs. So this is where the log command line tool comes into play. So we're going to look at this. But if you're a developer, you can use Xcode to read the log files to the app you're developing is a login. And there's also a framework you can use. It's a bit limited, but there's a framework that has got some basic functionality to actually read the logs in code as well. So how does this all hang together? So a typical log so when you're logging, you're creating messages, and each message has a log level. So there are 3 basic log levels, which are default, info, and debug. So Apple described default as essential for troubleshooting. The info one is helpful, but not so useful for troubleshooting. So it's more like information. And there's a debug one which developers can use to give you kind of really detailed information. So each message will have one of these, possibly one of these 3 log levels. So these are the kind of 3 basic ones. And then there's 2 special ones. There's error and fault. So error is used to log errors that happen during execution of your code or developer's application. And fault is where something's really gone bad. Like for instance, you've got a bug in your application, and that's where the faults come in. So we have 5 log levels, 3 basic and kind of 2 special. Now on top of that, we have categories and also subsystems. So every message is associated with a subsystem and a category. The subsystem is used to identify the application or even part of an application that generated the message. So, for instance, you might have a simple program that only has one subsystem, or you might have a more complex program that is made up of multiple components. And so each component will have a subsystem specific for that part of the application. And you identify the subsystem via using standard reverse DNS notation that we're kind of used to with the Apple systems. So it's normally the reverse DNS of the domain of the vendor, and then appended to that will be the application. So for instance, com.example.myapp. So hopefully it makes it quite straightforward to start identifying applications within the logs. So we have these subsystems. And then we have categories. So categories are just arbitrary kind of tags the developer can choose to tag their messages. So these will identify a specific part of the application, and it's really down to the developer to pick these. So for instance, you might have one for networking logs, one for maybe authentication, one for maybe in-app purchase, whatever it may be, basically. So again, we can use these to start targeting the logs you're interested in. So you can use a subsystem to identify the application, and then maybe a category to then kind of narrow down the part of the application you're interested in. So as an example, I might have one application called Project X, so it's got a unique subsystem. I may only have one category, it's down to the developer, but then you've got a second application called Project Y, and that might have multiple categories. So by using a combination of subsystem and category, we can start narrowing or kind of focusing on the logs that we're kind of interested in. Now, also, each log has 2 characteristics that can be set, and there is a default, but this can be changed either for the entire system or for a specific subsystem, or even for a certain category. So these 2 characteristics are, is that log level enabled? So for instance, is debug enabled? And is it persistent? So is that message stored in disk, or is it in memory only? So if it's in disk, it's going to be persistent. If it's in memory, it will get flushed and won't be persistent. So there are some defaults we can look at. So for instance, the default message level is always enabled, and that's persistent, goes to disk. Info is enabled, but can be disabled, and it's not persistent by default. By default, it goes to memory. And then the debug is not actually enabled by default, so there's no destination, okay? And then error and fault are always enabled, and they're persistent. Now, these can be changed, so you can actually change these for a specific application, specific category. So at the end of the talk, there's going to be a link to a GitHub repo where you can go and get this slide deck, but also there'll be some kind of more advanced examples of how you can check what log level is enabled for a certain subsystem, and then change that if you need to. Okay. So let's look at the log command. So the log command is used to interrogate our logs in Unified Login. So we've got the console app, which is that UI app everyone's probably seen, but that can only look at kind of live logs that happen in real time. It can't search historical logs. So the log command line tool is much more useful. So if you just type log by itself, you get a reasonably useful help page, usage page. So if you want to do a stream, so if you want to just look at the logs in real time, if you just enter log stream in your console as an admin, then this will start streaming the logs, and it just continuously stream the logs forever until you decide to stop it just by exiting it. Okay, so we can do the same functionality as the console app, but the more useful side of it is getting to the historical logs. So with this, we can use LogShow. So if you enter LogShow and hit return, that will stream to the screen. Sorry, that would show to the screen all the logs that have been that are currently available. So going back to the very first ones that have been saved. So with this, you can get back to all the historical logs. Now, when you first run this, you're going to get pages and pages of logs. You're going to get probably about a couple of weeks of logs or content. So obviously, it's not that useful when you just do this. So at some point, you also need to go through and start searching and filtering these logs. Now, one thing to kind of point out, when you use the log command line tool, and it's the same for the console, by default, the info and debug messages aren't shown. It's only going to show you default and the fault and the errors. So if you want to show the default one, you can append to the LogShow command --info, and that would then include the info messages. And then if you do --debug, that will include the debug messages and also info. So there's a hierarchy here. So if you turn debug on, then you're going to get debug and info. So if you need those messages, just append that argument to LogShow or to LogStream, and you get the additional logs that have been generated. So as I mentioned, you're going to get a lot of information, probably too much. So ideally, you want to start filtering these log messages. Now, there's many ways you can filter this. We can filter on subsystem, on event messages, but also we can do it on kind of date and time constraints. Okay, so for instance, you might have maybe a customer or an end user who had an issue and they know what time it happened, that there's a certain period of time it happened, or it keeps repeating itself. So instead of looking at the entire log system, you can specify date and time constraints just to narrow the logs you're looking for. Okay, and then we've got a couple of options here. The first option is with the last argument. So if you do --last, you can then specify how long to the end of the log system you want those messages. So for instance, if you do --last 1m, that's for 1 minute. So you get the last minute's worth of logs. 1h is 1 hour. You got 1 day, and also a useful one is boot. So if you do last boot, then that's going to give you log messages from the last time the Mac booted or the device booted to the end of the log system. So that will give you messages relevant to the end of the log system. But you can also specify a specific date and time. So if you know when an event happens, you can specify start time by using --start. And then you can specify a date and a time using the format that's shown on the screen. Okay, so then that'll give messages from that start point to the end of the logs. And likewise, we have a --end, so that gives you events to that date and time from the beginning. Okay, so you've got a bit of flexibility here, and you can merge them. So if you want to do a range, you can then specify a start date and an end date, and that'll give you a range of logs between those two dates and times. Okay. So you can filter on date and time, which is quite useful. Now, obviously, at this point, you're still going to get a lot of information because you're going to get all the logs between those time periods. So the next part we're going to look at is filtering based on what's called a predicate. So a predicate allows you to filter the logs based on maybe a subsystem or a category or any other data that's available. So it's basically search criteria. So we can then perform searches on the logs within the system. So to do that, we're going to do a LogShow. So we want to get to the historical logs. And then to define a predicate, we do --predicate. And then what follows is the search criteria. So it gets a bit complicated now because we're going to start putting loads of quotes in, etc. So the whole predicate you want to define will be wrapped within single quotes. Okay, so you do --predicate, and then you've got the single quotes. And what goes between the single quotes is your search criteria. So as an example, if I wanted to search for a specific subsystem, I could specify the keyword subsystem and double equals, and then in double quotes, I can name the subsystem I'm interested in. So in this case, I'm looking for an app called PS Mac Logger from DataJar. Okay. So double equals is an exact match. Okay, so it's going to look for any subsystem that has exactly that specific subsystem. Okay, and then you hit enter, and you're going to get all the logs back based on that particular predicate. So that's a subsystem. If you want to search on a specific category, it's the same again. So you do LogShow --predicate, single quotes, and then you can specify a category as a keyword, and then double equals, and then you can specify the quotes and put in the name of the category. So this will now return any message that has a network category. And we can combine these. Okay, so maybe you want to search for a specific subsystem and a specific category. So we can create a slightly more complicated predicate now. So we can first of all define our subsystem as we did before, and then we can use the AND keyword because we want to search for this and that. So it's kind of a Boolean. So we want two items to be kind of true. So that after the AND, I can then name the category. In this case, network. So now I'm looking for a specific subsystem with a specific category of network. Okay, and then you get results back. And I can then merge this with date and time categories. So I can then say, well, actually, give me back those messages for that subsystem and category from the last 5 minutes, or from a specific date range. So I can specify start and end date. Okay, so you can very quickly start creating very complex search criteria just to kind of narrow down the information you're interested in the system. So that's a subsystem and categories. It might be you want to search actually on the message. So, for instance, you might be troubleshooting an issue, and there's a specific message you want to search on. So, to search messages, we use the event message keywords. And in this example, instead of using double equals, I'm using contains because double equals is an exact match. So, but contains is a partial match. So, in this example, we're going to look for the string foobar across every event message. So long as the messages contain foobar, then it's going to find them. Okay. If I'd use double equals, then it'd be an exact match, and it would only show me messages that only has foobar as a message. Okay. So contains is a partial match, and again we can search event messages, which can be quite useful. And again, we can expand this. So here I've got an example where I'm searching on a specific subsystem, specific category, and I'm looking for that event message. Okay, so I'm further narrowing down what I'm looking for. Other useful options is if, for instance, you don't know the subsystem, or maybe the application hasn't got a subsystem it's logging via, an alternative way is to actually search on the process name. So this is the same process name you see in Activity Monitor. So, for instance, if I wanted to search for messages from Safari, I could have used a subsystem of com.apple.safari, but I can also use a process name. So here I'm just searching for any messages that originated from the process Safari. And again, this could be obviously any process from Activity Monitor. Okay, so it gives you a nice alternative to the subsystem. But just to complicate things, there's two versions of the process keyword. We have process, which searches for a process called X that is running or has logged a message. We also have a version called process image path, which is subtly different. So the difference is process, you just name the process, whereas process image path, you define the path on the file system to where that process lives. Okay, so this can be sometimes useful if you maybe want to troubleshoot maybe like a command line tool, but you've got an alternative version installed. So you have the original version in the default location, but you have another version somewhere else, and you only want to capture that specific one. So you can use process image path and use a path to where that command line tool sits on the file system. Okay, so I've got some examples here. So some will work, some won't. So the first example is using the process keyword. So that's just looking for any logs that originate from sudo. So if there are results, it will return them. The second example, we've got process image path equals sudo. That's going to fail because process image path is expecting an absolute path to where that process sits, and because it's double equals, it's an exact match, and we haven't specified an exact path basically. So that's going to fail. But I could use contains, and that would work because it would look for any logs that has a path registered that contains sudo. So that would work. Or I could use double equals and specify the actual path to where that process sits. Okay, so you've got some alternatives. So you've got process and process image path. And then the final one is sender. So sender is slightly different. So process is the actual process, the application that originated the message. But it might be that some messages you're looking for are coming from maybe some libraries or frameworks that the application is using. So instead you can use sender. So sender will let you search for maybe a framework or kernel extension rather than the application itself. And we also have sender image path, which is the same as process image path, where you have to pass it the actual path to the framework or library you're using. Okay, so sometimes these can be useful if you're trying to kind of do a more deep dive into kind of troubleshooting. We mentioned AND, so we used AND to search for a subsystem and a category. There's an OR keyword, so you can use OR to find one item or another item. So in this case, we're looking for either the Safari process or the mail process, or messages that come from this. So we'll get both Safari and mail event messages coming back. Okay, so that's an OR. But if you start mixing ANDs and ORs, you have to be slightly careful about your logic now. So in this example, what we want to do is we want to find messages that originate from either su or sudo, but where they were executed from the command line. Okay, because other processes can run sudo or su. So to do this, we can search the event message for TTY. So this is one way to identify whether these processes were executed from the command line by a user, because their event messages will contain TTY. So this example won't give you exactly what you want, okay? Because the way it's going to execute this or do the logic is it's going to first of all do the first process. So it's going to find any event message that originates from su, no matter how su was enacted, okay? So you're going to get all messages which come from su, or any message that comes from the sudo process that also has the event message of TTY. So here we've got a kind of partial correct results. The sudo part's correct, but the su part's incorrect. Okay, so what we want is basically su with TTY and sudo with TTY. So this is where brackets come in useful. You can use brackets to kind of change the priority of what gets kind of evaluated first. So if we put the brackets around the two process arguments, they would get executed first. So it's now going to look for either the su process or the sudo process that also has TTY in the event message, and now we get what we want. Okay, so just be slightly careful about the grouping if you are mixing ands and ors in your predicate. One thing to be careful: predicates are case sensitive. So, for instance, this will fail because I haven't specified the correct casing for Safari, so that would fail. So obviously I could correct that with the correct casing, but you can do casing sensitive comparisons. So after your comparison operator, if you just do square brackets and put a C inside it, that would do a casing sensitive comparison. So this will now work, and you can also use it with contains or any of the other operators. Okay, so square bracket C will do a case insensitive search or comparison. And likewise, I can use begins with. We haven't seen this one yet. So we had contains, but begins with was check the beginning of in this case, a process that matches those characters I specified. And I also got ends with, so I can check the end of the name of a process. So you've got quite a few comparison operators just to check, either exact matches, partial matches. Does it end with X? Does it end or start with Y? So yeah, it's quite useful and quite versatile. So this is kind of a list of what we can do. So we've seen double equals. You can do not equals, greater than, less than, greater than, equal. We've got our AND logic. We've got ORs. We've also got NOT, which is kind of an inverted logic. So not this. And some of these have alternate versions. So for instance, for AND, we can use the AND keyword or double ampersand. They both do the same thing. Okay. And likewise, we saw begins with, contains, ends with. We've got like, so like is quite useful. That will let you use wildcard characters like question marks and asterisks to do like wildcard characters. And if you're into regex, you can use matches. So you can then specify a regex string to do your comparison as well. So yeah, lots of options to kind of do your searches with. Apple got some good documentation on predicate, so that URL will take you to the developer documentation, and there's some nice examples there on how predicates work from Apple's point of view. Just some bits and pieces. So if you want to search for specific message types, so maybe you want to see info messages, there's a message type argument, and then you can just pass in either info, debug, error, or fault. or they've got predefined numbers, so you can pass in the relevant number as well. Okay, so you can use those just to filter based on message type. Okay, and you can also archive the logs. So the logs will get rotated eventually. So if you want to export them, we can export them to a log archive file, which then can be read later on, either via the log command or via the console application. So to create the archive, on your sudo command log, you just do a collect, and then you can specify your criteria, and then use the output argument, and you can save it to a file, for instance, in this case, on desktop. And that will create a .log archive file, which can be used later on. So it's quite useful to collect these log files for later use, because eventually they will get rotated around and you lose them. Okay, so this is quite useful. So as I mentioned, you can open these archives up either in the console app, or if you want to open it up in the log command, just do LogShow and then point it to the archive file where it currently sits. Okay. But really useful is you can also grab log files from other devices like iOS devices, iPads or iPhones. So you can attach the device via USB cable. So long as you trust, you click or tap the trust button when it pops up on the device, you can use the log command to collect the logs from that device. So you can just do a sudo log collect, and then you can either specify the device name or the UDID of that device if you know it. And then you've got the same parameters. So in this case, I'm looking for a device called iPad that's been attached to this Mac. And I can specify the criteria, and I can then do an output, and then it just grab those logs and save it to desktop. And I can now look at them at my leisure. Okay. So one of the other things you can do is you can change the log style. So you've got that default log style that gets generated to the console. But if you want to pass these log files to maybe to another system, or you've got a script you want to pass it, you can actually change the style. So there's a couple of really useful JSON ones here, and there's also one for syslog. So again, you can just change the format by specifying the style argument, and you can switch it over. So I've used JSON in the past where I needed to pass that log file with another script as an example. We mentioned privacy. So Apple does, like most of their frameworks, the security and privacy is part of their kind of ethos. So the unified login system does attempt to stop personal data leaking, and what's considered private is really any dynamic data in the application. So things like collections, like arrays and dictionaries, because they're dynamic. If the application tries to log those, unified login will redact it. So as an example on the screen, I've tried to log out the password from an application, and the password's been redacted because it's private. Now, you can override this, and this is something I wouldn't recommend to do unless you've really got a need for it. But it is possible to turn the redaction off, so it does start logging these messages. So in 10.12 and 10.14, this could be done with a mode command, and you can turn private data on or off. But this is slightly too easy and slightly too dangerous, because you could just do this from a single command. So since 10.15.3, that command was removed, and now you can use a configuration profile. So there's an example of one at George Garside's website you can download, and it still works. I tried it on Monterey recently, and it still worked. So you can push this out via an MDM, and it will turn that redaction off. But again, use with caution. It's not something that we recommend. Okay. And then finally, there are some useful third-party tools out there. The great folks at Electric Light Company, they've got some really good kind of third-party apps that have been written to use unified login. So there's one called Albo, which is basically a kind of a dumbed-down, simple, easy-to-use log browser. There's one called Constellation, which is much more advanced. So it lets you create those predicates we looked at within the UI. And there's one called Mints, which is a selection of tools that are kind of got pre-saved predicates. So, for instance, there's one for Time Machine, one for iCloud, one for like the login window. So they're kind of pre-built in, and by clicking a button, you can get those logs immediately. And also, if you've got like you want to use unified login maybe with a script or something that's not like a native app, they've got a command line tool called Blowhole, which will allow you to log via that command line tool from your script or whatever you're doing, basically. So again, some really useful tools. So I hope that's enjoyable and useful. So this is the GitHub repo I mentioned. So the complete slide deck is going to be in here, and there's going to be a load of examples of using predicates and unified login in there as well, and a bit more information as well, where I didn't have time to actually go through it. So yeah, thank you for listening.